Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the concepts of bilinear form. This question is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 704112. This question is suitable for all these examinations. Right. The given question is: consider the bilinear form B from r power 4 cross r power 4 to r defined by b of x comma y is equal to x1 y3 plus x2 y4 minus x3 y1 minus x4 y2, where x is a quadruple given by x1 x2 x3 x4 and y is also a quadruple y1 y2 y3 y4 in r power 4. Let A denote the matrix of the bilinear form B with respect to the standard ordered basis of r power 4. Which of the following statements is true? We are given 4 options. Option 1, determinant of A is equal to 0. Option 2, determinant of A not equal to, determinant of A is equal to minus 1, right? Determinant of A is equal to minus 1. And option 3, B of x comma x is not equal to 0 for all non-zero x belongs to r to the power of 4. Option 4, if x belongs to r to the power of 4 is non-zero, then there exists a y belongs to r to the power of 4 such that b of x comma y not equal to 0. Right. Let's now discuss the solution of the problem in detail. We are given the bilinear form B from r power 4 cross r power 4 to r defined by b of x comma y is equal to x1 y3 plus x2 y4 minus x3 y1 minus x4 y2, where x and y are quadruples denoted by x1 x2 x3 x4 and y1 y2 y3 y4 respectively in r power 4. Now, it is given b of x comma y is equal to x transpose capital A y, where A is the matrix of B with respect to the standard ordered basis of r to the power of 4. Right. That is, the matrix A will be given by, B is a 4 by 4 matrix whose first row is B of E1 comma E1, B of E1 comma E2, B E1 comma E3, B E1 comma E4. That's the first row. Similarly, second row, third row, fourth row is written. And here the B of B E1 comma E1 is what? Is the coefficient of x1 y1. B E1 E2 is the coefficient of x1 y2. So likewise, so if you see Bxy, x1 y3, the coefficient is 1. So that means B of E1 E3 must be 1. x2 y4, the coefficient is 1. So B E2 E4 is 1. And the coefficient of x3 y1 is minus 1. So B of E3 E1 is minus 1. And minus x to the power of 4, x4 y2, that means x4 y2, the coefficient is minus 1, b e4 e2 is minus 1. So write down the matrix A. Yes, that's what we were talking about. Now we are ready. So let's call on options. Option 1, determinant of A is equal to 0. Option 2, determinant of A is equal to minus 1. Let us take determinant of A is equal to, expand the matrix A, the determinant A through its first row. So it will be 1 times, delete first row and the third column. The resultant minor is 0, 0, 1, minus 1, 0, 0, 0, minus 1, 0. Now that is equal to 1 into this expanding by first row. It will be 1 into delete first row, and the third column you will get minus 1 into minus 1 plus 1 minus 0. That is 1. So determinant of A is 1, and which is 1. Therefore the option 1 is not true, and the option 2 is also not true. Right. So let's see, go to the option 3. B of x comma x not equal to 0 for all non-zero x belongs to r to the power of 4. Right. Let x is equal to x1, x2, x3, x4, the quadruple belonging to r to the power of 4, x not equal to 0 means at least one of these x1, x2, x3, x4 is non-zero. One of the components is not 0. Then b of x comma x is equal to x1, x3 plus x2, x4 minus x3, x1 minus x4, x2 is 0. The cancellation takes place, 0, and at least one of them is not 0. Is okay. Right. So the cancellation takes place and it will be 0. So the option given is it is not equal to 0 for all non-zero. For all non-zero vector x belongs to r to the power of 4. Therefore, the option 3 is not true. All the 3 options are found to be not true. So obviously this is a part B question. Therefore, option 4 must be true. Yes, we will show you how the option 4 is true. Right. Option 4. If x belongs to r to the power of is non-zero, it's a non-zero vector, then there exists a vector y belongs to r to the power of 4, a y belongs to r to the power of 4, such that b of x comma y not equal to 0 comma 0, not equal to 0. Right. Let x is equal to the quadruple x1, x2, x3, x4 belongs to r to the power of 4. X is non-zero. That means at least one of the components of x is non-zero. Agreed. Now let y is equal to, you take y as minus x3 comma minus x4 comma minus x1, x2. That means y1 is minus x3, y2 is minus x4, y3 is x1, y4 is x2. Right. With this, b of x comma y is equal to x1, y3 plus x2, y4 minus x3, y1 minus x4, y2. Substitute x1, y3 is x1 plus x2, y4 is x2 minus x3, y1 is minus x3 minus x4 into y2 is minus x4. Now multiply, you will get x1 square plus x2 square plus x3 square plus x4 square, and it is x is given to be a non-zero vector. At least one of the components is not 0. One of the components is not 0. So the sums of the squares is not equal to 0. Is not 0. Since x is equal to x1, x2, x3, x4 belongs to r to the power of 4 and x is a non-zero vector. Thus, if x belongs to r to the power of 4 is non-zero, then there exists a y is equal to minus x3, minus x4, x1, x2 belongs to r to the power of 4, such that the bilinear form b of x comma y is not equal to 0. Thus, the option 4 is true. Right. Summarizing all the options, the answer to this question is option 4. That is the detailed discussion of the solution of this problem. It is definitely an easy question. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.